Hello guys, and welcome once more to this video into our YouTube channel. So in today's video we are going to be solving a very interesting question on linear transformation. The question with the linear transformation is represented by the matrix M equals the matrix given to us. The Roman one we are asked to find the image of the line R equals to I minus 3j minus 4k plus c open bracket I plus j minus k. Let us actually launch into the solution of this question. The first thing we are going to do, we are going to first of all try to expand this vector equation of the line. Okay, in order for us to simply group its I, j and k terms together. That is, doing that we are going to obtain R to be equal to 2 plus t I, then plus t minus 3j, then plus negative 4 minus t k, from which we can therefore conclude that the x, y and z coordinates of the vector equation of the line is actually going to be equal to 2t, t minus 3, negative 4 minus t respectively. Now, since the equation we are being told that what? We are being told that the linear transformation is presented by the matrix M. So M is the transformation. So M here, being the transformation matrix, is going to transform a certain point R to an image R prime. So in this particular question, we are simply going to be looking for R prime, which corresponds to the image of the line given to us in this particular question here. Okay, so saying that, we can therefore let R prime to be the image, obviously, which we are looking for. That's the image of the line R. Let R prime be equal to x, y and z, from which we can therefore come and say that what? This transformation matrix then times the point which we have determined by simply simplifying the vector equation of the line, okay, then to be equal to the image which we are looking for. That is the image of the line R given to us in the equation. For which we can therefore move forward and further simplify. That is by doing 1 times 2 plus c, we get this, then plus negative 1 times this, we get this, plus 1 times this, we get it, and so on. That's if we multiply this matrix times this point, okay, and we equate it to the image which we are looking for, that is x, y and z. So multiplying this matrix times this point, we get this expression by simply respecting the methodology which I gave in first place, that is row times the column. We are going to get this expression. Well, we can therefore move forward and further simplify again to get x, y and z, which correspond to the coordinates of the image of the point, that's the coordinate of the image of the line R given to us in the equation, to be equal to, the x coordinate is going to be equal to 1 minus t, the y coordinate is going to be 14 plus 5t, and the z coordinate is going to be negative 7 simply, from which we can therefore move forward and further simplify again, that is, write it in terms of R prime, because remember R prime is actually the image of that line R which we are looking for. So R prime is going to be equal to 1 minus t, 14 plus 5t and negative 7 as x, y and z coordinates respectively. When we can therefore come forward and group it as such, that is the I term, j terms and the k term. That is 1 minus t is a k, is a I term, that is the coefficient of the I term, 14 plus 5t is the coefficient of the j term, and negative 7 is the coefficient of the k term, from which we can therefore move forward and bring it into its vector form. Very important, because in the equation the line was given to us in vector form, so we must bring back that line, that's this image. We must bring back this image which we obtained into what was given initially in the equation, that is in its vector form simply. For we therefore get that required image of the line R which we are looking for actually in the equation. So in the next equation we are asked to find the image of the plane x plus y minus z equals 3 under M, under the transformation matrix M. So here, what are we going to do? Obviously, M again being the transformation matrix, we are obviously finding what? We are finding the image of the plane. Okay, so in this particular question we are finding B prime, because we have been told that M here is still a transformation matrix. So M is still used as a transformation matrix. So we can therefore come forward and first of all write back this our plane. Okay, that is x plus y minus z equals to. Now what are we going to do? We are going to let x be equals to A and y be equals to B. So we are going to assume 2 points on the plane. That is, we are going to let x be equals to A and y be equals to B. Saying that, it implies we can therefore obtain the different expression of z, because x being equals to A, y being equals to B, and z being equals to x plus y minus 3, we therefore get z to be equals to A plus B minus 3. Why? Because if we factor out z from here, we are going to have x plus y minus 3. Knowing that we let x to be equals to A, y to be equals to B, we can therefore conclude that z is actually A plus B minus 3. So from which we can therefore move forward and say that the point which the matrix M is going to transform is actually A, B, and then A plus B minus 3. So from it, you can help come forward and let, first of all, let P prime be the image of the plane x plus y minus z equals 3, which we want to find. So we are looking for B prime actually, which is the image of the plane so far. So obviously, we are being told that we are asked to find the image under still M being the transformation matrix. We can therefore come forward and multiply this matrix M, the transformation matrix, times the point which we obtain here to be equal to x prime, y prime, and z prime, which are actually what we are looking for here. But you can therefore move forward and further simplify. That is row times column. Multiply this matrix, this transformation matrix, times this point. We get this expression by simply doing row times column. That is 1 times A, we get A. The negative 1 times B, we get negative B. Then plus 1 times all this expression, we get this. And we do same for the others. We get this expression. Or finally, for we can therefore move forward and further simplify again. We get x prime, y prime, and z prime to be equal to 2a minus 3, a minus 2b plus 6, 2b plus a minus 3 respectively. So from which we can therefore come forward and first of all let those three equations, that is, let x prime be equation 1, that's the expression of x prime being equation 1, the expression of y prime be equation 2, and the expression of z prime be equation 3. Now what are we trying to do? Remember, we are trying to obtain what are we trying to do? In fact, we are trying to bring down, because as I said, in the equation, the plane was given to us normally, so we must come back again and get the image in terms of this equation of the plane given to us. So we must bring it down, as we did for the Romans one. That is, for the Romans one, we brought back that equation into its vector form. So that's what we are going to do here. We are going to transform that. We are going to obtain a plane actually from these coordinates of the image which we obtained so far. So the first part that we're going to do, we can observe that from equation 2, we can get the expression for 2b. So from equation 2, 2b actually is equal to a minus y prime plus 6. Now what are we going to do with this 2b? With this 2b, we can come and substitute this 2b inside this equation 3. That is, substituting 2b in equation 3, we get what? We get z prime to be equal to a minus y prime, then plus 6, plus a minus 3 to be z prime actually. So having then z prime, we can therefore come forward and first simplify and get a. Why are we doing this? We are doing this because since we have z in terms of y prime and in terms of a, and in equation 1 we have x prime which is only in terms of a. So we can clearly make a the sort of the formula here in terms of z prime and y prime and substitute it inside equation 1, which is in terms of actually x prime and a. And doing that, obviously we are going to get a relation between x prime, y prime, and z prime, which we are actually looking for in this particular equation. So doing that, that's equation 1 is going to become x prime is going to be equal to 2 times z prime. That x prime is going to be 2 times z prime divided by 2 plus y prime divided by 2 minus 3 divided by 2, then minus 3, for which, for that simplifying, we get what? We get x prime to be equal to, then this 2 and this 2 is going to cancel, to be equal to z prime, then plus y prime, then minus 6. Take note, because we are going to have here these 2 and this 2 are going to cancel. We are going to have left negative 3, then minus 3. We get therefore negative 6, and which is actually the image of the plane. Remember, as I said, we took the image which we obtained in terms of coordinates and brought it back into the equation of a plane normally, as we know. That is the equation therefore of that plane. That is the image of the plane x plus y minus z equals 3 under transformation matrix M is actually going to be equal to x prime minus z prime minus y prime to be actually equals to 6.